Welcome back to part 5 of our Godot Masterclass. In the last video we learned the basics of GDScript, but writing code that works is only half the battle. Writing clean code isn't just about aesthetics, it's what keeps your game maintainable and scalable when you return to a file months later or work in a team. Godot empowers developers with its revamped GDScript 2.0 and enhanced static typing. Today we are bridging the gap between beginner script and software engineer. We'll cover GDScript patterns, custom classes, safe node access, and how to debug your game like a pro when things inevitably break. Let's dive in. With GDScript, you should always favor typed variables. It's easy to write variable health equals 100, but writing variable health integer equals 100 gives you massive advantages. First, the Godot editor can catch type mismatches during development, helping you avoid bugs. Second, the engine can optimize the performance better with typed variables. This becomes incredibly noticeable in large projects where untyped code adds up slower execution paths. The same rule applies to functions. By typing bool at the end of a function, you can tell anyone reading the code and the engine that this function always returns a true or false value. Another clean code rule is to avoid magic numbers. Instead of writing random numbers throughout your code, define constants that clearly explain their purpose. For example, constant walk speed, float 200. This is not only easier to understand, but also makes future balancing work much quicker. You can change one value in one place. When you need to access child nodes, accessing them directly inside the ready function often leads to bugs when nodes aren't available yet due to race conditions or scene inheritance. The recommended way is to use the @onReady keyword. By declaring a variable with @onReady, Godot waits until the scene is initialized before trying to resolve them. You avoid writing manual getNode calls in the ready function, which makes your code less cluttered and easier to read. Godot 4 now supports typed signals, which means you can define what kind of data is passed when emitting a signal. By defining signal damaged amount integer, you avoid surprises and prevent silent bugs caused by mismatched signal parameters. As your game grows, you need reusable structures. Custom classes in Godot 4 let you define your own reusable types, whether you're modeling characters, inventory items, or environmental parameters. By using the class name keyword at the top of a script, like class name weapon data, you give yourself full editor support. You can then go into your player's script and export a typed variable, such as @export variable equipped weapon data. You just turned what would have been raw dictionary lookups or duplicated code into a clean modular system. You can also give enums to define behaviors, like enum behavior type passive aggressive, to make your AI scalable. Finally, GDScript 2.0 supports typed collections. By writing variable spellbook array spell data, Godot will throw a warning if someone accidentally adds a non-spell item to that array, preventing bugs before they even happen. Eventually, your code is going to break. Debugging and logging are your essential tools for uncovering the root causes of these issues. In GDScript, the print function outputs to the output panel, which works great for checking variable values. However, in larger projects, your logs can become messy. Prefixing your logs with consistent tags, like typing player before the message, can help you quickly filter output. For logging errors without crashing the game, use push error. This message appears in the debugger's errors tab, helping you catch problems that aren't fatal but shouldn't happen. When you need to pause time, you can insert a breakpoint in your GDScript file by clicking the line number in the script editor. When the game hits that line, It will pause execution and open the debugger tab, allowing you to inspect variables in the current scope. From there, you can step into, over, or continue execution to track how the values evolve. Lastly, to catch math errors during development, use the assert function. For example, assert amount is less than or equal to 0 assures that if amount drops below 0, then the error will pop up in the output saying damage cannot be negative and highlight the issue immediately. Using static typing, safe initialization with @onReady, signal definitions with types, and breaking logic into reusable components, all of this helps you think and code like an engineer, not just a scripter. If this video helped you clean up your Godot projects, please drop a like and hit subscribe. In the next video, we are diving into the true backbone of 2D and 3D game development, Game Math Explained, where we will master vectors, positioning, and how vector math actually controls your game's movement. Keep learning, keep building. I'll see you in the next video.